How 20,000 G fuses turned American artillery into a meat grinder. Introduction. Steel rain over the jungle. The air hung thick and humid, heavy with the scent of damp earth, decaying vegetation, and the metallic tang of fear. Ryota, hunched deep within a shallow depression, pressed himself against the unforgiving soil, his heart a frantic drum against his ribs. The relentless thunder of American artillery was a familiar symphony of dread, a constant companion in the suffocating heat of Okinawa. He knew its rhythms, the distant rumble of the guns, the rising crescendo of incoming shells, the earth-shattering impact as they slammed into rock and jungle, sending geysers of mud and shrapnel skyward. But this day, the sound was different. The whistle of the approaching projectiles carried an unfamiliar, unnerving quality, a sharper, more insistent note that pricked at his instincts. Then came the new sound, not the expected, deafening roar of an impact against the ground or a cliff face, but a dry, snapping crack, somewhere impossibly above the very canopy of trees. It was a sound that defied logic, a violation of the understood rules of engagement. And then, from the heavens, metal began to rain down. It wasn't the scattered, unpredictable spray of ricocheting shrapnel, nor the sporadic debris from a direct hit. This was a steady, methodical downpour of steel and fire, a horrifying deluge that seemed to seek out every crevice, every foxhole, every desperate attempt at concealment. It poured into the craters, plastered itself against the reverse slopes, and tore through the dense foliage as if it were tissue paper. This wasn't a battle anymore. It was a slaughter. Ryota had never witnessed anything like it. The jungle, usually a sanctuary of shadows and concealment, had become a killing ground, an open stage for an unseen, merciless force. The methodical, relentless shower of death seemed to have no origin point, no discernible pattern, only a horrifying, all-encompassing presence. It was as if the sky itself had decided to turn against them, shedding layers of lethal shrapnel with an efficiency that was both terrifying and utterly demoralizing. Every rustle of leaves, every crack of a branch, became a potential harbinger of a steel shard, tearing through flesh and bone. The screams of his comrades, often cut short by the sudden, brutal impact, echoed in the oppressive air, further cementing the horrifying reality of their situation. This was not the war he knew. This was something far more insidious, far more final. The very concept of cover had been rendered meaningless, and with it, any hope of survival under such an onslaught. This terrifying new reality, this steel rain, was the direct result of one of the most closely guarded secrets of World War II. The radio proximity fuse, often referred to simply as the VT fuse, variable time fuse, stood as one of the United States' 3 paramount secret projects of the era, sharing its clandestine status and groundbreaking importance with the atomic bomb and radar technology. While the atomic bomb would ultimately bring the war to a definitive end and radar revolutionized air and naval warfare, the VT fuse was quietly transforming the effectiveness of conventional artillery, turning it into a weapon of unprecedented lethality, especially in the brutal, close-quarters combat of the Pacific Theater. Its development, shrouded in secrecy and demanding an extraordinary leap in engineering prowess, was about to rewrite the rules of land warfare, beginning with the desperate struggles in the jungles and on the beaches of the Pacific Islands. Section 1. Stalemate, Coconut Grove against Steel. The war in the Pacific was a conflict unlike any other, a brutal clash fought across vast oceans and on countless small, unforgiving islands. For the American forces, particularly the Marine Corps and Army infantry, the enemy was not just the Japanese soldier, but also the very landscape itself. The verdant, dense jungles, the labyrinthine cave systems, and the craggy, volcanic terrain provided the perfect canvas for a defensive strategy that would prove incredibly difficult to overcome. From the earliest landings, American forces encountered a highly organized and deeply entrenched foe whose tactical doctrine was meticulously designed to inflict maximum casualties while minimizing their own, and crucially, to prolong every engagement. Japanese defensive tactics throughout the Pacific Theater of Operations, PTO, placed a paramount emphasis on creating deeply echelon networks of bunkers, natural and artificial caves, and subterranean tunnels. These complex systems were not merely isolated strongpoints. They were intricately connected, forming formidable underground fortresses that could withstand the most intense bombardments. Commanders understood the inherent strength of fighting from prepared positions, especially against a technologically superior adversary. They meticulously selected terrain that offered natural concealment and defensive advantages, then augmented it with reinforced concrete, logs, and earth, transforming hillsides and coral outcrops into impregnable bastions. These fortresses were engineering marvels of a brutal war. Caves were expanded and reinforced, sometimes with multiple entrances and exits, often leading to interconnected tunnels that could stretch for hundreds of meters. Within these subterranean complexes, Japanese soldiers could store ammunition, food, and water, shelter from artillery fire, and even conduct field hospitals. Machine gun nests were often built into the mouths of caves or heavily fortified bunkers, providing interlocking fields of fire that could sweep attacking forces with devastating precision. On hills and ridges, positions were dug into the reverse slopes, making them invisible and inaccessible to direct fire from naval guns or conventional artillery. The entire philosophy was to absorb the initial shock of an amphibious landing and then bleed the invading forces dry in a protracted, attritional struggle. Against such a deeply ingrained and resilient defensive strategy, standard American artillery, utilizing conventional impact fuses, found itself in a frustrating and often impotent position. A standard impact fuse, designed to detonate upon striking a solid object, was highly effective at destroying surface fortifications, leveling buildings, and cratering open ground. When a shell with an impact fuse struck a bunker, it would explode, hopefully breaching the walls or collapsing the structure. If it hit an exposed trench line, it could inflict heavy casualties. However, the Japanese had adapted. Their fortifications were often so robust, or so deeply buried, that even direct hits from heavy artillery might only chip away at the exterior or simply fail to penetrate the thick layers of rock and concrete. More critically, these standard shells were almost entirely useless against Japanese soldiers who were either safely ensconced within their underground cavities or positioned on the reverse slopes of hills. A shell exploding on the crest of a ridge, while visually impressive, would send its lethal fragments primarily forward and outward, largely missing any enemy forces tucked away on the opposite side. Similarly, a shell detonating on the ground above a cave system would expend its energy harmlessly, creating a crater while the occupants below remained relatively safe, albeit shaken. The earth itself became a formidable shield, absorbing the blast and shrapnel before it could reach the entrenched defenders. The very design of the impact fuse, its strength when meeting resistance, became its critical weakness when faced with an enemy determined to avoid direct impact. It was a tactical conundrum. How do you kill an enemy who isn't there to be hit? This inherent limitation of standard artillery gave rise to a bitter, sardonic humor among American Marines and infantrymen, a dark coping mechanism born from frustration and repeated, costly assaults. A particularly prevalent and disheartening joke circulated. Our artillery is great for transplanting coconut trees. The Japanese just crawl out of their holes after the shelling and start shooting. This jibe, delivered with a weary laugh, encapsulated the grim reality faced by ground troops. They would endure hours of deafening bombardment, watch as the jungle was torn apart, and then, expecting to find shattered, demoralized remnants, they would instead be met with fierce, well-organized resistance from seemingly untouched positions. The impression was that the artillery was merely rearranging the landscape, not destroying the enemy. The palm trees might be uprooted or shredded, but the deeply dug-in Japanese soldiers remained, ready to unleash a storm of rifle and machine gun fire the moment the friendly barrage lifted. The sentiment of helplessness and the feeling of fighting a ghost enemy are vividly captured in the recollections of American infantrymen from that period. One such veteran recounted the harrowing experience. "We waited for hours while our guns churned up the hill. We went in to attack and they were already waiting for us. It felt like suicide." This quote underscores the profound psychological toll this stalemate took on the attacking forces. The anticipation of an artillery barrage was always accompanied by the hope that it would soften the enemy, reduce their numbers, and pave the way for a less perilous advance. When that hope was repeatedly dashed, when the enemy emerged from their unseen sanctuaries seemingly unscathed and ready to fight, the courage required to press the attack morphed into something akin to resignation. Each assault became a grim lottery, a gamble against an enemy who seemed impervious to the very weapons designed to break them. The sheer futility of expending vast amounts of ammunition only to face an enemy still capable of mounting a tenacious defense was a demoralizing cycle that led to heavy casualties and prolonged, brutal engagements across countless islands in the Pacific. Section 2. The Wonder Fuse, Technology Born in a Hell of G-Forces. The desperate stalemate in the Pacific, where the immutability of Japanese defenses seemed to mock the destructive power of conventional American artillery, underscored an urgent need for a radical shift in approach. The existing tools were insufficient to dislodge an enemy so deeply entrenched, so adept at leveraging the terrain. What was required was not merely more firepower, but a fundamentally different application of that power. The solution, a marvel of ingenuity and sheer industrial determination, lay in a piece of technology so complex, so delicate in its core components, yet so robust in its final form that its very existence seemed to defy the laws of physics: the radio proximity fuse. The core challenge in developing such a fuse for artillery shells was not the concept of proximity detonation itself, which had been explored for anti-aircraft applications. The true genius and immense difficulty lay in making this sophisticated electronic device survive the unfathomable stresses of being fired from a cannon. When a shell, such as those fired from a 105mm or 155mm howitzer, is propelled down the gun barrel, it undergoes an acceleration that generates colossal forces. This immense and instantaneous acceleration subjects the projectile, and everything within it, to stresses reaching an astounding 20,000 gs. To put this in perspective, astronauts experience a mere fraction of this during rocket launches, and even highly engineered military aircraft are designed to withstand only a few tens of gs. 20,000 gs is a force that would instantly crush and atomize any ordinary electronic component, rendering it utterly useless. Wires would snap, solder joints would shatter, and the delicate glass and metal structures of vacuum tubes, the bedrock of electronics at the time, would implode. The engineers tasked with this seemingly impossible feat faced a monumental hurdle. They had to design a miniature radar system, complete with a tiny transmitter, receiver, amplifier, and power source, all of which could withstand a force that would turn solid steel into a crumpled mess if not engineered with extreme precision. The sheer violence of the gun launch meant that every single component, down to the smallest filament, had to be reimagined, reinforced, and fundamentally re-engineered to survive. It was an unprecedented test of material science and electronic robustness. One of the most critical and challenging components was the vacuum tube, the heart of any electronic circuit in the 1940s. These tubes, analogous to modern transistors, were inherently fragile, consisting of delicate glass envelopes, intricate internal electrode structures, and fine tungsten filaments that had to glow to function. For them to survive 20,000 gs was not just an engineering problem. It bordered on an alchemical transformation. Yet, the brilliant engineers at the Crosley Corporation, a key player in the fuse's development, devised a revolutionary method to achieve this. They developed a specialized process where the extremely thin, fragile tungsten filaments of the vacuum tubes, which were the heat-generating and electron-emitting elements, were suspended in a vacuum within the glass bulb. Crucially, these filaments were then literally fused or melted into the glass of the envelope using high-frequency electrical current. This innovative technique created an incredibly robust, monolithic structure where the filament was not merely supported, but became an integral, stress-resistant part of the tube's architecture. It minimized any potential for movement or vibration that would lead to breakage under extreme acceleration, essentially eliminating the weakest link in the chain. This meticulous, almost artisanal approach to manufacturing, combined with radical innovations in component design, was what ultimately allowed the VT fuse to function. The achievement went far beyond a simple invention. It was a profound demonstration of American industrial might and the zenith of its engineering prowess during the war. It wasn't enough to conceive of the idea. The nation's manufacturing base had to be mobilized and innovated upon to produce these incredibly complex devices on a mass scale, to a level of precision and durability previously thought impossible. Factories were retooled, new production lines were established, and specialized techniques were developed to ensure that every single fuse could withstand the brutal journey down the gun barrel and perform its intended function with reliability. The entire ecosystem of research, development, and manufacturing had to operate in perfect synergy, under immense pressure and secrecy, to bring this wonder fuse to fruition. Reflecting on this Herculean effort, one of the engineers involved in the project famously remarked, "We made radio tubes survive what no human being could. It was a battle of physics against material science, and we won." This quote encapsulates the monumental nature of their achievement. They had pushed the boundaries of what was considered physically possible, forcing delicate electronic components to endure forces that would liquefy biological matter. It was a triumph not just of specific designs, but of an entire ethos of relentless problem-solving, iterative innovation, and unwavering belief in the power of engineering to overcome seemingly insurmountable obstacles. The victory was not just in creating a single functional fuse, but in establishing a manufacturing process that could reliably reproduce hundreds of thousands of them, each capable of enduring the hell of G-forces and then performing its crucial war-changing task. The wonder fuse was ready to make its debut, and the battlefield was about to be irrevocably transformed. Section 3, First Call. Enigma for Japanese Command. With the wonder fuse successfully engineered and manufactured, the time came to deploy this revolutionary technology on the battlefield. Its first significant, widespread application in field artillery, marking a crucial turning point in the Pacific Campaign, occurred during the intense fighting for the Gulf of Leyte in the Philippines. This was not a tentative trial but a decisive commitment of a highly secret and incredibly effective new weapon, designed to break the stalemate that had characterized so much of the ground combat against entrenched Japanese forces. The immediate impact of the VT-fused shells was palpable on the Japanese side, though its true nature remained shrouded in mystery for some time. Reports from Japanese units during this period began to be filled with references to unusually effective and super-accurate enemy artillery fire. These were not the usual assessments of American bombardments. There was a distinct sense that something fundamental had changed. Commanders and soldiers alike noted that the barrages seemed to reach them even when they were in previously safe positions, or that the sheer density of shrapnel seemed unprecedented. Initially, these observations were often attributed to coincidence, perhaps an unusually lucky series of hits, or to the introduction of a new type of conventional high-explosive shell with enhanced fragmentation. The idea that a technological leap was behind it seemed, at first, too radical to fully grasp. The standard explanation for increased effectiveness was often sought within the known parameters of artillery warfare, perhaps better targeting, improved logistics, or simply a greater volume of fire. However, the persistent nature of this unusually effective fire began to sow seeds of doubt and confusion. Japanese intelligence was, in fact, aware of the existence of radio proximity fuses used by the Allies in anti-aircraft defense. These airborne VT fuses had been a significant factor in downing Japanese aircraft, drastically increasing the lethality of Allied anti-aircraft batteries. The concept of a fuse that could detonate near an aerial target without direct impact was known to them, albeit likely understood as a specialized, expensive, and complex piece of technology strictly for air-to-air or ground-to-air engagements. What seemed absurd and wasteful to the Japanese command was the very idea that this expensive and intricate technology could be expended on firing at ground targets, particularly at infantry. Their understanding of military logistics and resource allocation suggested that such a sophisticated device would be reserved for high-value targets, not for general bombardment. Why use a radio-controlled detonation mechanism, a miniature radar, to kill individual soldiers or disrupt dug-in positions, when simpler, cheaper impact fuses could achieve similar results, or so they thought? This fundamental miscalculation of American industrial capacity and tactical flexibility prevented them from immediately connecting the dots between the known anti-aircraft VT fuse and the new, terrifyingly effective ground artillery. They simply could not conceive that such a valuable asset would be mass-produced and deployed so liberally against ground forces, especially given their own limitations in producing similar advanced electronics. The cost-benefit analysis, from their perspective, did not justify such an expenditure. This psychological shock, the profound bewilderment caused by the new, inexplicable lethality of American artillery, often proved to be as impactful as the physical destruction itself. The Japanese commanders and soldiers initially sought explanations within the framework of familiar tactics and existing technological capabilities. They searched for patterns that made sense in the context of conventional warfare. Better spotting, more concentrated barrages, or perhaps a new type of shell that simply had a wider blast radius. The thought of a fundamental technological leap, a complete reimagining of how artillery shells functioned, was beyond their immediate grasp. They struggled to process a reality where shells were no longer confined to exploding upon impact, but could detonate precisely where they would cause maximum damage to personnel, even those shielded from direct hits or tucked away on reverse slopes. This inability to quickly identify and understand the nature of the threat meant that valuable time was lost in devising effective countermeasures or adapting defensive strategies. The unusually effective fire remained an enigma, an unsettling anomaly that steadily chipped away at morale and effectiveness, foreshadowing the even greater horrors that were soon to come. Section 4. Okinawa. The meat grinder gets a name. If the battles of Leyte Gulf offered a glimpse into the devastating potential of the VT fuse in ground combat, the ferocious, protracted struggle for Okinawa became its definitive, horrifying showcase. This island, a mere 350 miles from the Japanese mainland, was to be the final, most brutal stepping stone in the Allied advance, and it was here that the full, horrifying impact of the Wonder Fuse earned its grim moniker, the meat grinder. The tactical application of artillery on Okinawa, spearheaded by the widespread use of VT-fused shells, reached an apex of efficiency and destructiveness, with catastrophic consequences for the Japanese army. On Okinawa, American artillery units perfected and extensively employed a devastating tactic known as the Ring of Fire. This strategy involved surrounding Japanese positions with a continuous, impenetrable curtain of shells equipped with VT fuses. Unlike conventional bombardments where shells impacted the ground, these projectiles were timed to detonate in the air, typically 10 to 30 feet above the target area. The effect was immediate and psychologically shattering. Instead of localized craters and forward-spreading shrapnel, these airbursts created a vast, uniform sphere of deadly fragmentation that rained down from above. This meant that every inch of the enemy position, every foxhole, every trench, and crucially, Even soldiers seeking cover on reverse slopes or within shallow depressions was exposed to a relentless, inescapable hail of steel. The ring of fire was designed not just to suppress or damage, but to create an inescapable kill zone, a veritable wall of shrapnel that made movement, counterattack, or even simple survival almost impossible. It was an evolution of artillery from a blunt instrument to a precision tool for mass destruction against dispersed, concealed infantry. The impact of this new form of warfare on the soldiers of the 32nd Japanese Army was nothing short of apocalyptic. Their deeply ingrained defensive tactics, honed over years of island hopping, suddenly became a death trap. The air above them was no longer a safe space. A vivid, almost poetic, artistic sketch captures the terror of this new reality. For the soldiers of the 32nd Japanese Army, the sky itself seemed to have fractured. There was no longer a rear or a front line. Whistle burst, whistle burst. The air hummed with steel splinters. Tree branches fell, shredded into kindling. Craters offered no salvation, death descended from above. After such a bombardment, the positions presented a gruesome spectacle. Shreds of uniforms, twisted weapons, a meat grinder, as it would later be called in reports. This description encapsulates the profound and horrifying shift in the nature of combat. The ubiquitous Japanese strategy of digging in, of utilizing every natural fold in the terrain, every cave and ravine for concealment, was rendered tragically obsolete. No longer could a soldier find refuge simply by going prone in a crater or by hunkering down on the unseen side of a ridge. The airbursts effectively bypassed these traditional forms of cover, projecting their lethal payloads directly down into every nook and cranny. The constant whistle, burst, became a torturous rhythm of impending doom. The jungle, once a protective ally, became a sieve through which death effortlessly poured. The sheer volume of shrapnel, combined with its downward trajectory, meant that even the thickest foliage was no barrier. Trees were not merely defoliated. Their branches were shredded into kindling, a testament to the concentrated power of the airbursts. The aftermath was a scene of utter devastation and carnage, so horrific that American forces inspecting the captured positions coined the term meat grinder. It wasn't just about dead bodies. It was about the utter pulverization of everything in the blast zone. Uniforms were not just torn but reduced to shreds. Weapons were not merely broken but twisted into unrecognizable forms, a testament to the immense energy released by the detonations. The phrase meat grinder perfectly captured the indiscriminate, wholesale destruction of human life and material, reducing organized units to a gruesome, mangled mess. The psychological toll on the Japanese defenders was immense, a factor often as decisive as the physical casualties. A surviving Japanese officer's vivid recollection offers a stark testament to this. "We prepared for everything, but not for this. Soldiers went mad. There was no way to attack, no way to retreat, no way to simply take cover. It was like being in a giant slaughtering machine." This quote provides a chilling insight into the terror and demoralization inflicted by the VT-fused artillery. The Japanese military doctrine, built on rigid discipline and fanatical resistance, began to crumble under a form of attack that rendered courage and sacrifice meaningless. The sense of being utterly trapped, with no viable defensive or offensive option, was soul-destroying. The term giant slaughtering machine accurately describes the feeling of helplessness and the systematic obliteration of their forces, orchestrated by an unseen, merciless mechanism raining death from above. Okinawa cemented the VT-fused reputation as a game-changer, turning the battlefield into a literal meat grinder for those caught within its deadly embrace. Section 5. Realization of failure. They didn't expect the unrelenting intensity and unprecedented lethality of American artillery on Okinawa, driven by the omnipresent threat of the VT-fused meat grinder, eventually forced a grim realization upon the Japanese command. As the battle wore on, with casualties mounting to unsustainable levels and morale plummeting under the constant, inescapable rain of steel, the nature of the weapon they faced became unmistakably clear. It was a moment of profound strategic failure, not in the sense of tactical blunders on the ground, but in the deeper failure to anticipate and adapt to a truly revolutionary technological leap by the enemy. By the latter stages of the Battle of Okinawa, the Japanese command, confronted with the devastating evidence of their disintegrating forces and the overwhelming effectiveness of the new artillery tactics, issued new orders. These directives, a stark departure from their deeply entrenched defensive doctrine, specifically instructed units to, as far as possible, avoid troop concentrations in open terrain. This was a direct acknowledgement of the VT-fuse power. Massing troops, a standard preparatory phase for counterattacks or defensive rotations, had become an open invitation to annihilation. The airbursting shells made short work of any densely packed formation, regardless of whether they were attempting to move or hold a position. Furthermore, the new orders emphasized a strategic shift towards relying on night sorties to minimize losses from the new type of artillery fire. Under the cloak of darkness, the effectiveness of the radar-triggered VT fuses was somewhat diminished, as direct observation and targeting became more difficult for American spotters. Night attacks, typically smaller in scale and focused on infiltration and close-quarters engagements, offered a slim chance of bypassing the devastating airburst barrages. This adaptive measure, though born of desperation, vividly illustrates the Japanese command's belated understanding of the weapon's nature. They recognized that the danger primarily emanated from above and during daylight, compelling them to alter fundamental operational procedures that had been staples of their fighting style throughout the war. The emphasis on avoiding open ground and moving under the cover of night was a clear, if belated, admission that their traditional methods of defense and counterattack were no longer viable in the face of this silent, descending death. The phrase, "The Japanese didn't expect that 20,000 G fuses would turn U.S. artillery into a meat grinder," stands as the quintessential summary of this entire conflict and the profound strategic misjudgment. This interpretation goes beyond merely stating that they were surprised by the technology. It points to a deeper underestimation. It wasn't just the existence of the technology itself that caught them off guard. It was the sheer scale of its application and the tactical flexibility with which the Americans deployed it. The Japanese had indeed been aware of proximity fuses for anti-aircraft use, and might have even theorized their potential for ground applications. However, their industrial capacity, their resource constraints, and perhaps their own strategic biases led them to believe that such a complex, expensive, and seemingly delicate device would never be mass-produced for conventional artillery use against ground forces. They failed to fully grasp the immense industrial capability of the United States and its willingness to invest heavily in technological superiority to save the lives of its soldiers. They underestimated the American capacity not just to invent, but to mass-produce and tactically innovate with such advanced weaponry. Their strategic thinking, bound by their own operational realities, simply did not allow for such a comprehensive and widespread deployment of wonder fuses. A fascinating and little-known fact that emerged after the war further underscores this point. When American specialists later studied captured Japanese archives and military reports, they made a startling discovery. Even after prolonged exposure to the meat grinder on Okinawa, Japanese engineers had never fully managed to decipher the exact operating principle of the VT fuse, nor had they been able to develop an effective countermeasure. Despite the devastating effects they witnessed, and the clear tactical adjustments they were forced to make, the internal workings and specific mechanisms that allowed the fuse to operate and survive 20,000 GS remained a mystery to them. This highlights not only the incredible secrecy surrounding the project but also the significant technological gap that had opened between the two nations. The inability to reverse engineer or even fully understand the device meant they could only react to its effects, not counter its cause. Their tactical adaptations, such as night movements, were evasive maneuvers, not direct counters, further cementing the VT-Fuse absolute dominance on the battlefield. The realization of failure came late, and without a clear understanding of the enemy's breakthrough, it was too late to mount a meaningful defense against the revolution in artillery warfare. Conclusion: a quiet revolution, a resounding result. The story of the 20000G fuses, the revolutionary radio proximity artillery fuse, is one that often remains in the shadow of other, more dramatic wartime innovations. Yet, its impact on the ground war, particularly in the unforgiving crucible of the Pacific theater, was nothing short of transformative. It marked a quiet revolution in military technology, a subtle yet profound shift in the lethality and effectiveness of conventional artillery, leading to a resounding result on the battlefield. The most tangible measure of this revolution lies in its quantitative impact. According to estimates, the effectiveness of artillery fire, specifically when employing VT fuses, dramatically increased by a factor of 5 to 10 times. This is a staggering figure, illustrating that the meat grinder was not merely a qualitative improvement but a monumental leap in the destructive power of a conventional weapon system. To increase the efficiency of a weapon by such an order of magnitude fundamentally alters the dynamics of combat. It meant that fewer shells were needed to achieve the same effect, or, more typically, that the same number of shells could inflict vastly more damage and casualties than ever before. This exponential increase in effectiveness translated directly into shattered enemy morale, obliterated defensive positions, and significantly reduced the tactical options available to the opposing forces. It effectively changed the cost-benefit analysis of defensive warfare, making deep entrenchment far more perilous and unsustainable. The historical narrative of World War II often places the atomic bomb as the definitive, ultimate weapon that brought the conflict to its swift and dramatic conclusion. While it is undeniable that the atomic bomb delivered the loud final chord to the global conflict, irrevocably ending the war with its devastating power, it was the meat grinder with its 20000G fuses that was arguably winning the war on the ground. This distinction is crucial. While the atomic bomb's strategic impact was immediate and absolute, the VT fuse was relentlessly grinding down enemy resistance day after day, island after island, saving thousands of lives of American soldiers by making their advances less costly. It systematically decimated the Japanese army with a terrifying and unprecedented efficiency. The meat grinder did not end the war with a single, spectacular flash, but rather through a relentless, attritional process that wore down and ultimately broke the Japanese will to resist in countless smaller engagements. It allowed American infantry to advance with a significantly reduced risk, knowing that the artillery had truly softened the enemy, instead of merely transplanting coconut trees. This saved untold numbers of American lives, fulfilling one of the primary motivations behind its highly secretive and urgent development. The VT fuse turned what was often a costly, agonizing infantry slog into a more manageable, albeit still brutal, advance by fundamentally altering the survival chances of the entrenched enemy. As one historian eloquently put it, if the atomic bomb was the loud final chord, then the radio fuse was the eerie, monotonous hum that accompanied the agony of the Japanese Empire on its last frontiers. It was a quiet, but no less deadly revolution. This powerful quote perfectly encapsulates the dual nature of these two transformative technologies. The atomic bomb, with its blinding flash and earth-shattering roar, undeniably heralded a new era of warfare and provided the ultimate impetus for surrender. But the radio fuse, operating with a less visible, less dramatic, yet utterly relentless efficiency, created a pervasive and inescapable terror on the battlefield. Its eerie, monotonous hum signifies the ceaseless, methodical destruction it wrought, a constant presence that signaled inescapable doom for the Japanese defenders. It was a revolution not of destructive yield in a single moment, but of tactical effectiveness across countless moments, reshaping the very experience of ground combat. In essence, the 20000G fuses represented a profound evolution in military science and application. They transformed artillery from a weapon often used for area denial and suppression into a precision instrument capable of delivering lethal fragmentation directly onto hidden personnel. This quiet revolution, born from an incredible feat of engineering and deployed with devastating tactical flexibility, left an indelible mark on World War II, playing a critical, though often unsung, role in the Allied victory in the Pacific. It proved that sometimes the most revolutionary changes come not with a bang, but with a silent, unseen descent of steel rain. Subscribe